Welcome to a new session of Circuits Networks. In today's class, we are going to see some basic definitions and concepts related to electrical electronics engineering. So here you can see the list of the definitions. What is active, passive elements, linear, non-linear, time varying, time invariant, lumped and distribution elements, unilateral, bilateral elements, dependent and independent sources. So before going to that, look into the circuit where you have passive elements and active elements like voltage source, battery VAB, current source IS. These are treated as active elements, and resistors, capacitors, inductors are treated as passive elements. So, what is the basic difference between circuit and network? In a network, you can have a connection from one terminal to another terminal, and in a network, you may or may not have a closed path. For example, here you have an open circuit. Here also you have an open circuit which is in series with current source, and here inductor you can see it is an open circuit. Whereas in circuit, strictly all the elements should be connected in a closed way, means every element should be connected to another, and its circuit should be a completely a closed one. Okay, so you can apply Kirchhoff's voltage law in a closed loop like this. Either you can apply a KVL over here, you can apply KVL once again over here, and you can apply also a KVL over here, because all are loops, individual loops. Whereas in this circuit you can see I can apply KVL in this closed path, and I cannot apply a KVL wherever there is an open circuit path. So that is the basic difference between a circuit and a network. And the basics of circuits and networks deals with the current, voltage, power, and the passive elements, that is resistors, inductors, and capacitors. When you look into the definition of current, it is defined as the rate of flow of charge, whereas a charge of electron is minus 1.602 into 10 to the power of minus 19 coulombs. So if at all you take it into the definition of current in mathematical way, I is equal to dq by dt, and in order to obtain the unit of current, the unit of charge is coulomb and unit of dt is second. So current units can be taken as coulombs per second or an ampere. You can see you have a battery over here which makes the current to flow through this particular conductor, where you have these electrons which are marked as negative in symbol. So when a current flows, the charge particles, they are attracted towards the positive terminal of the battery. Similarly, you can define voltage, that is a voltage is developed when an external force, or we call as electromotive force, is required to move electron from one point to another point. It is also defined as a voltage, and the mathematical value of voltage can be written as dW by dQ, where the work done can be taken into the terms of unit as joules, and charge can be taken in terms of coulombs, or this is regarded as a volt. The unit of a voltage is nothing but it is volt. It is treated as volt. When you take the time rate of energy, that is treated as electrical power, where power units are obtained to be joules per second or simply watts. Mathematically, you can take dW by dQ multiplied with dQ by dt, which gives you the value of power as V into I. So these are the basics of uh, current, voltage, and power in electrical and electronic engineering. Apart from this, you have active elements. The elements which give energy to other elements connected to them are termed as active elements. Example, voltage sources and current sources. When you look into the circuit, you can see VAB, VS, and VIS are the voltage sources. Oh, sorry, are the active sources or active elements. And the passive elements, the elements which receives energy from the other elements connected to them, are treated as passive elements. Examples are resistors, inductors, and capacitors. In the circuit, you can see R1, C1, L1, or R2, C2, L2 as an examples. The AC voltage source is given by this symbol, whereas a DC source can be a battery or a voltage represented by in this fashion plus or minus. The passive elements are resistor, inductor, and capacitor. Another definition which we have to focus is on linear elements, elements that follow Ohm's law, that is V equal to IR, and have a constant relationship between voltage and current. Example, resistor. And nonlinear elements are the elements where the voltage current relationships are not constant. Example, a diode or a transistor. Time varying elements are the elements whose parameters change over time. Examples are semiconductor devices or varistors. And time invariant elements are the elements with constant properties over time. Fixed resistor is an example, or an inductor is an example for time invariant element. Another definition is the lumped elements. The parameters like RLC are assumed to be connected or concentrated at a single point. Example, circuit components in the small circuits, like what we have seen in the previous circuit diagram. Resistor, inductor, capacitor, if they are closed, they can be written as a lumped elements. Whereas the distributed elements, the parameters are spread over space. The entire circuit, what we have seen in our first figure, it resembles distributed network or distributed elements. Example of such networks will be applicable in transmission lines and antennas. Unilateral elements allow current to flow only in one direction, especially example of a switch or it's a diode. A bilateral element allow current to flow in both directions. Example, you can take these passive elements where you can have the direction of current flowing from one direction to another direction. Next is the independent sources. If the behavior of any current or voltage source does not depend upon some other sources, then they are categorized as independent sources. Example, you can see a 6 amperes of current source, a 20 volts of DC source, or 100 at an angle 0 degrees an AC voltage source. A dependent sources is regarded if the behavior of any current or voltage source depends upon some other sources, then they are categorized as dependent sources. So dependent sources are also defined as those sources whose values depends on a voltage or current elsewhere in the network. Different classifications of dependent sources you can see here. We have voltage control voltage source regarded as VCVS, or current control voltage source regarded as CCVS, or a voltage control current source regarded as VCCS, and a current control current source treated as CCCS. Or symbolically, you can see here a voltage control voltage source, a current control voltage source, and a voltage controlled current source, and finally a current controlled current source. So that's all for today's class. In the next class, we are going to see the basic definitions of Kirchhoff's voltage law, current law, Ohm's law, and we'll see the applications of active elements and passive elements. Please share among your friends, subscribe to this channel, and please press the bell icon for the future notifications.